Hi everybody, welcome to another video in course Algebra, section 4.3, properties of logarithms. We have more properties of logarithms in this section. Before we go there, let's recall that we have the property of exponent. When we multiply, it becomes addition, and when we divide, it becomes a difference and power to another power. We multiply those powers. Now, with that, we have equivalent. Multiply, turn into a plus. Subtract is division. And then from here, we can take the power outside as a coefficient. So those are the properties, right? So log addition. Now I just want to show one of them, see how that works. Log base b of m times n. Let's say that equal to x. So we swap b to the x is equal to m times n. Or does that help? Not very much. Let's look at the other one. Right. What we look at is this. So swap to exponential form doesn't help. But what we can do is break both sides to the exponent for b. So b to power of both sides. Base b and base b cancel out. We have m times n. And we will write this as b log base b of m plus log base b of n. Now, the addition from the right hand side to the left, and it becomes b to the log base b of m times b to log base b of n. Base b cancel out, base b cancel out. I'll just have m times n. So that's the proof of it. So that's why these formulas are analog to this. Bottom line is, if it is a division, it's going to be turned into subtraction of the logs. If it is multiply, turn to addition of the log. Right. So first, what we see here is division. So we're going to subtract the log, two logs. Right. Now we have addition. We can split that in two. And that becomes addition. Notice that this negative sign or affect everything with whole log here. So that's why I put in the bracket. So that negative will affect the whole thing here. So distribute the negative. We have log base 2z cubed minus log base 2 of x plus log base 2 of y to the fifth. Of course, that would be wrong. The negative here distributed to here and there. So this would be negative. And the last properties is we can take out the power, the exponent outside as a coefficient. So I have log base 2 z, there's a 3 moving outside, log base 2 of x, 5 log base 2 of y. Right, so that's what we have. Notice that when we do a lot of this problem, we come up with the rules here that if it is on the top, it's going to be positive coefficient. If it is at the bottom, there are two of them still have negative coefficient. So if we have positive, or if we have anything on the top, we have positive coefficient. If we have terms at the bottom of the log, it will be negative coefficient. Right, that helps. Right, notice that and last step we can check the number outside. Alright, now for this one we don't see the base here, but that is a common log, so it's base 10. I'm going to just put 10 here. Right, the cube root I will turn into the 1/3 power. Right, because let's say anything to the cube root of anything, by default b to the first power itself, so you can write b to the 1/3. That's what we have here. Right, now we cannot split them yet because of the 1/3 in the way. So first we will take that, bring outside as an exponent. Right, now that on the top, that at the bottom, the 1/3 though is multiplied to the whole thing. So if we switch if we split, it will affect the whole thing. By the way, we don't need to write log base 10. And then we can take the 2 outside here. And the log base 10 of 100. 100 is 10 square. So base 10 and base 10 cancel out, just 2. By the way, on the calculator, I didn't show this on the previous section because I want to just rely on the properties. We can just say log of 100. Right? If we want base 10, some calculator has it, some don't. It may, if your calculator have it, it will be in this option. Anyway, that is 2. So this will be 1/3 2 log base 10 of x plus y minus 2, and then we'll multiply it out. 2 times 1/3, 2/3 log base 10, or just log. The common log, we don't need to write the base. And 2 times 1/3. Right. So that's what we have. Notice that log of x plus y, or of any base, we cannot simplify it. We can only do it if it is the product, the quotient, or the power. Product, quotient, and power. This is a plus. We cannot do anything. Right. So I remember one thing we write, if it is on the top, it will have the positive coefficient. If it is at the bottom, it will have negative coefficient. So here we have 2 terms on the top. So in that case, by the way, Ln is the log base e So we have ln of the first term still on the top, so still plus, and then the c to the 9 at the bottom. Right, and then the fourth and the 9 coefficient come out for ln of a plus ln of b minus 9 ln of c. Right. Once again, on the top, carry a positive coefficient. At the bottom, negative coefficient. Same thing here. Log base 5, the cube root of 25. Because that on the top, at the bottom. Right. Now, of course, we can put that in the calculator, but let's just simplify it by hand. 25, I can write 25 to the 1/3 power. And here we cannot do much except bring down the 2. Yeah, we can bring down to 1/3. By the way, 25 we can write 5 square. Base 5 of the log, base 5 of the exponent, so that's just 2. And log base a of b, we cannot do anything. If it is a product, quotient, or power, we can do it, but not a sum or the difference. Multiply, and so that's all we have in this problem. Right, so that is called expanding. We have one big log, and we turn that into a bunch of little logs. Now we do it in reverse order. It's called condensing. We have a bunch of logs. Now combine that into one big logs. So when we combine this is the same rule. If it's positive, if it's on the top, it will have the positive coefficient. So the same thing, if it have positive coefficient, it will have to be on the top. So you have 560 on the top, 7 and 5 at the bottom. Right? Now just simplify. 7 times 5 is 35. 560 divided by 35 is 16. And we can write as 2 to the 4th power. Base of 2, base of 2. Of course, if we do this, and just quickly, if we don't know how to do either of that, the definition will be good enough. Write that equal to x, and then swap 2 to the x is equal to 16, and then 16 is 2 to the 4th, so x is equal to 4. Right, so that's the definition from logarithmic form to exponential form. Or we just use the properties, or even the calculator work as well. Right, so if it's on the top, carry the positive coefficient. If it is at the bottom, carry a negative coefficient. But in order to combine them, we have to have one of each log. So one of this log, one of this log, and one of that log. So first I'm going to take all the coefficient inside. So we have one of each log. By the way, this is base 10, or the common log. Base 10 right? Now we have one of each log, which will combine to one big log, one of each, then combine to one. The positive will stay on top, this negative at the bottom, positive on top. Right, so that's pretty much it. Of course, if we want to simplify this one step further, we can use a cube and then the root. The top, for that, we can write the power 3, and the bottom is the root. Same thing here. The top is the power, the bottom, index of radical. Square root, we don't really need to write the 2 here. So we just have log square root of b at the bottom, a cube, and square root of c cube on the top. So that is condensing or expanding. For expanding, remember the log, we can only do log of a product, log of a quotient, and log of a power. And when we condense or combine to one big log, we have to have one for each in order to combine. And anything on the top will carry a positive coefficient. Anything at the bottom will be negative coefficient. Next, we have chain of base formula. What happens if we cannot put this in a calculator? By the way, most scientific calculators have the ln, the base, the natural log, and the base 10, the common log. Right. But it cannot have, it may or may not have the log of a particular base. Bottom line is we may or may not have this option to enter that. Right. So in that case, we just simply choose what we call the chain of base formula. So we go from base B to base A. The way we do that is we just take the log of any other base up to the argument and log of that other base to base B. So we have x on the above, b below. So we have log of any base of x divided by log of b. But since we have the calculator of the common log and the natural log, we usually just use this. Log base b of x is ln of x divided by ln of b, or log of x divided by log of b. So in this case, if we want to estimate log base 4 to 135, we would say this is equal to ln of 135 over ln of 4. Of course, if you don't want to use ln, we can always use the common log, or any other base will do. So I just use ln here, ln of 135, the natural log of 135. Close that, divide by the natural log of 4. Close it. And we have 3.5384. Right. If we do this directly, we should get the same thing. Or if we use log base 10, should get the same thing. Either way, that's what we have. Right. Now, and finally we get to the back to the question at the beginning of the section. What is 2 to what power is equal to 10? So in this case, we can say, we write this as logarithmic form, and we switch 10 and x. The base is 2 though, right? The 10 goes here and the x goes there. So pretty much x is equal to log base 2 of 10. Base 2 of 10, which can be approximate as ln of 2 over ln of 10 over ln of 2, exactly equal to ln of 10 over ln of 2. And we use a calculator to get the estimate. And that is 3.32. say 2. Right? So it's simple enough. Right? So that is the trainer base formula. So if the calculator do not do the log of any base, we use the trainer base formula, either that or that. Right. And finally, just gonna answer this question. Let's say we have ln of 2 is that. So 0.693 and ln of 3 is 1.099. Ask you what is ln of 12. So say if that is the question, of course we put ln of 12 on the calculator, but let's say we don't, we only have ln of 2, ln of 3. How do we get to ln of 12? Well, in that case we can just write 12, 2 times 6, 2 times 3, so 12 is 2 squared times 3. We split into ln of 2 squared plus ln of 3 and take the 2 outside. And now we have ln of 2, ln of 3. Substitute the values, we have ln of 12. Right. So this is one application of the properties that we have at the beginning of the section. But that's all I want to cover in this section. Thank you for watching, and see you in another video in course algebra.